Historical Model of an Atom Project by Kate McMahon, Abby Oline, Logan Aids, and Gavin Hartnett. Background A. Historical information about Ernest Rutherford. Born August 30th, 1871, and died October 19th, 1937. Was a British New Zealand physicist. Rutherford was the central figure in the study of radioactivity. His concept of the nuclear atom, he led the exploration of nuclear physics. He won the Nobel Prize for Chemistry in 1908, was president of the Royal Society and the British Association for the Advancement of Science, was conferred the Order of Merit in 1925, and was raised to the peerage as Lord Rutherford of Nelson in 1931. Rutherford attended free state schools through 1886, but won a scholarship to attend Nelson Collegiate School, which is a private secondary school. He excelled in mathematics and science. Background B. When were the experiments conducted and when were they published? Ernest Rutherford reversed Thomson's atomic model by discovering the nucleus of the atom in 1911. 5 years earlier, he started conducting experiments from his curiosity.
Experiments. Ernest Marsden and Hans Geiger, under the guidance of Rutherford, used the gold foil experiment to show that an atom has a heavy nucleus and that the mass of an atom is spread out. The results of the experiment were surprising and were repeated multiple times, even by Rutherford himself. The results being that alpha particles passed through the gold foil, while some particles deflected back at large angles. Rutherford performed this revolutionary experiment with Ernest Marsden and Hans Geiger after he was awarded the Nobel Prize in 1908. This experiment took some patience, as only a small number of alpha particles were concentrated on the nucleus of the atom. Rutherford's model precedes Thomson's plum pudding model and Dalton's model, while also leading into Bohr's model used today.
Rutherford's model. When Rutherford was carrying out his experiment, he discovered that a majority of the alpha particles fired at the golden foil passed straight through it, but a small number of the particles were deflected at a very large angle, and some even came back toward the radiation source. The reason this occurred was because of the dense positive charge within the nucleus. This was a surprise to Rutherford and the other researchers because it was much different than what Thomson's model had stated. Rutherford concluded that all of the positive charges were not floating around in a big cloud, Thomson's plum pudding model. Rather, they were concentrated in a dense nucleus in the center of the atom, and that the nucleus only took up a very small portion of the atom, which led him to the conclusion that an atom is made up of mostly empty space. In 1919, Rutherford discovered the basic unit of positive charge in the atom and named it the proton. Publication and refinement. Rutherford published his model in 1911, but he still had one aspect of it that he was unable to explain, and that was why the negatively charged electrons remained in orbit when in theory they should have immediately fallen to the positively charged nucleus. The explanation to this seemingly unsolvable problem came in 1913, when Niels Bohr formulated his solar system model, which stated that negatively charged electrons only exist in a certain orbital pattern.